So test is tomorrow, so I'm just going to go through really quick and do a couple, or go through this review, so in case you're working on it at home and you have questions, I can answer this for you. Let me get my stuff. I should have done this first. Okay, so first thing on the top, it says evaluate the expression 17 minus 4y for y equals 5. Is the result a real number? Okay, for it to be real, okay, what's inside the radical has to be positive. Okay, as long as what's under the radical is positive, then it's going to be a real number. So if I plug in a 5, I get the square root of 17 minus 20. So that's the square root of negative 3. So automatically it's not real because it's a negative. Here, 3 times 7 is 21 minus 11. 21 minus 11 is 10. So that's the square root of 10. That's a positive number. So yes, that is real. Okay, down here when we're simplifying, okay, these are just basic, up here, easy ones. Okay, the square root of y to the 20th is y to the 10th. The square root of 81 is 9. Then down here, okay, it's a trinomial, and every trinomial that we have is going to factor into a trinomial square. So the square root of x squared is x. This is a plus, so it's two of the same. It's two minuses. 8 times 8 is 64, but negative 8 plus negative 8 is negative 16. So the square root of x minus 8 squared is just x minus 8. And then over here, the square root of 100 is 10, and the square root of 8 to the 12th is 8 to the 6th. And that's it. So moving on, determine the values of each variable. Determine the values of the variable that make each expression a real number. So again, real just means it has to be positive under the square root. So that means what's underneath the square root has to be greater than or equal to 0. So I'm going to add 9, 3x is greater than or equal to 9, so x has to be greater than or equal to 3. And over here, okay, the square root of 6x, so 6x just has to be greater than or equal to 0. Divide by 6, so x has to be greater than or equal to 0. That's the only requirement. Okay, on the next section, which is multiply, what we're doing is multiplying them together. So 6 times 8 is 48. Then what I want to see is if there's any perfect square factors of 48. So to make 48, okay, I can do 16 times 3, and then the square root of 16 is 4, right? So 4 comes out, 3 is still left inside, and then I'm done. Let's look at number 9. So on number 9, 12 times 5 is 60, and then I have m to the 6th, n to the 3rd. So I'm wanting to split these to make perfect squares. So 60, I can do 4 times 15, m to the 6th, I'm going to leave because it's an even number, n to the 3rd, I'm going to make n squared times n. So now the square root of 4 is 2, the square root of m to the 6th is m to the 3rd, the square root of n squared is n, and inside I'm left with 15n. And then the last one, 20 times 2 is 40, x to the 13th, y to the 4th. So to make 40, I can do 4 times 10, x to the 12th times x, y to the 4th. So the square root of 4 is 2, the square root of x to the 12th is x to the 6th, the square root of y to the 4th is y squared, and then inside I have 10x. And I know I'm done because 10 doesn't have any perfect square factors, so there's nothing I can do. Okay, so now to the last section, okay, which is probably the hardest section. If they're both inside a radical, okay, we want to see if we can simplify anything first. So 80 divided by 20 is 4. Y over y cancels. The square root of 4 is 2. Okay, and it's just that easy. 56 and 40, those are both divisible by 8. 56 divided by 8 is 7. 40 divided by 8 is 5. Okay, so we've done that, but now we have to figure out, remember it's like illegal okay, to have a radical in the denominator. So I'm going to multiply both of them by the square root of 5. So now the square root of 7 times the square root of 5 is the square root of 35. The square root of 5 times the square root of 5 is 5. Okay, and I can't simplify because one's in a radical, one is not. Okay, and this has no perfect square factors, so I'm done. On the next one, there's nothing I can do to square root of 5 or square root of y. So I'm going to rationalize it by multiplying the top and the bottom both by y. So I have the square root of 5y over y. And that's it. And then the very last one, okay, 2, I'm going to make this 2 times the square root of x to the 4th x over 3 times the square root of 25 times 2. Okay, so on the top, the square root of x to the 4th is x squared, and I'm left with an x. On the bottom, the square root of 25 is 5, so 3 times 5 is 15, square root of 2. Draw a line. Okay, so I'm getting closer, but I cannot have the square root down here, so I rationalize it by multiplying the top and the bottom by the square root of 2. So now I have 2x squared times the square root of 2x over the square root of 2 times the square root of 2 is 2. 2 times 15 is 30. And the very last step on this one is that 2 and 30 are both divisible by 2. So x squared times the square root of 2x over 15. Okay, and that one was pretty complicated, so that would be, gosh, I don't think I would even probably have anything quite that difficult. Okay, but that is as hard as it would get. Okay, next page. Adding and subtracting. In order to add or subtract, they have to have the exact same radicand. Okay, so what's inside the radical has to be the same. So you have to start off by simplifying. 48, I can do 16 times 3, and then x to the 10th. And 75, I can do 25 times 3. So the square root of 16 is 4. The square root of x to the 10th is x to the 5th. And then I have radical 3. And then over here, the square root of 25 is 5 times the square root of 3. So what's going to happen, they both have the same radical, so I'm going to add together what's on the outside. So 4x to the 5th plus 5. Those are not like terms, so I can't add them together. All I can do is write them as a sum times the square root of 3. And I'm done. Okay, let's look at the next one. It's the square root of 9 times 5 plus the square root of 4 times 5. So 9 becomes 3 square root of 5, and 4, 2 square root of 5. So 3 square root of 5 plus 2 square roots of 5 is 5 square roots of 5. Okay, Pythagorean theorem. Pythagorean theorem is a squared plus b squared is c squared, where a and b are the legs, they're the ones that make up the right angle, and c is the hypotenuse. So I have 4 times the square root of 3 squared plus b squared equals 10 squared. When I'm squaring 4 square roots of 3, okay, I have 4 squared is 16 times the square root of 3 squared, which is just 3, plus b squared equals 100. So I just want to make sure we all understood that. So that's 4 times the square root of 3 times 4 times the square root of 3. So 4 times 4 is 16. Square root of 3 times square root of 3 is 3. So that's where I got that from. So 48 plus b squared is 100. So I'm going to subtract 48 to get b squared is 52. Then the last step is to take the square root of both sides. So the square root of b squared is b, and then 52, let's see, gosh, I should have done this before, 4, 8, 12, is 4 times 13. So the square root of 4 is 2, and then inside is 13. So 2 times the square root of 13. Okay, and then the second to last section, okay, for solving, these should be pretty simple. Okay, you want to get the radical by itself. So subtract 5. The square root of y minus 5 is 6. Then I square both sides. So I have y minus 5 is 36. So y would be 41. Okay, next section or next problem, square, square. X plus 4 is 64. Subtract 4, x is 60. Okay, and if you think about it, 60 plus 4 is 64. The square root of 64 is 8. Okay, 41 minus 5 is 36. The square root of 36 is 6. 5 plus 6 is 11. Subtract 2. The square root of x minus 1 is 2. Squared, squared. X minus 1 is 4. Add 1, x is 5. 5 minus 1 is 4. The square root of 4 is 2. 2 plus 2 is 4. Okay, the last problem is kind of like the Big Daddy problems. Okay, so I'm going to leave what's outside. Negative 4, x, y, z. Okay, then I have 196. So I'm going kind of through my list of what it's divisible by. I know, let's see, 49 times, oh, duh. Okay, sorry. Hello. The square root of 196, that's a perfect square. Okay, so 196 is a perfect square. X squared times x makes x to the third, y to the 8th, z to the 10th. Okay, so now when I go through, the square root of 196 is 14. The square root of x squared is x. The square root of y to the 8th is y to the 4th. And the square root of z to the 10th is z to the 5th. So outside, 14 times negative 4 is negative 56. X squared, y to the, let me write this, negative 56, x to the 2nd, y to the 5th, z to the 6th, and inside all that's left is x. Okay, and then the very last problem. Okay, so 3m is on the outside. To make 175, I do 25 times 7. Then m to the 9th, I'm making m to the 8th times n, and then n to the 6th, times n. So the square root of 25 is 5. The square root of m to the 8th is m to the 4th. The square root of n to the 6th is n to the 3rd. So on the outside, I have 15, m to the 5th, n to the 3rd. And inside, I have 7, m, n. And I'm done. Okay, if you guys have specific questions or you need help on other things, okay, feel free to shoot me an email. Like I said, okay, your test tomorrow is going to be about 40 questions, so shorter, okay, significantly than the other practices that we've been doing, but a little bit longer than this one. Okay, but this, I did try to pick the hardest or harder kind of problems that are going to be on there. So if you can handle this, okay, you should be fine to go for tomorrow.